Question 1. In a context of optimizing a procedure that processes millions of rows from a sales table, Ramirez notices that each insert within a for loop causes significant performance degradation. What should Ramirez implement to reduce context switches and improve throughput? A. Use explicit cursors with bulk, collect, and for all for DML orations. B. Replace the for loop with multiple nested loops to isolate insert statements. C. Convert the table to a temporary table to perform inserts row by row. D. Disable exception handling within the loop to avoid overhead. Answer. Correct answer. A. Using bulk collect with for all minimizes context switches between SQL and ESQL engines, significantly improving performance when processing large datasets. Nested loops with individual inserts increase overhead and degrade performance. Temporary tables with row-by-row processing do not solve the context switch problem. Disabling exception handling is unsafe and will not address performance issues. It only risks integrity and does not optimize bulk operations. Question 2. Given the circumstances where a package maintains shared cursors and a developer wants to avoid exposing internal state, which approach ensures proper encapsulation and state management? A. Declare all variables and cursors in the package body as private. B. Expose all cursors in the package specification for external reuse. C. Store cursors in global temporary tables to maintain session state. D. Use autonomous transactions for each cursor execution. Answer. Correct answer. D. Autonomous transactions isolate the execution of cursors from the main transaction, allowing state to be preserved without exposing internal variables externally. Private variables in the package body enhance encapsulation but do not manage session-specific state. Exposing cursors in the specification breaks encapsulation and risks misuse. Using temporary tables unnecessarily complicates state management and is less efficient. Autonomous transaction handling for cursor operations. Question 3. While examining a airlock, Mr. Chowdhury encounters multiple nested exception handlers. He wants to ensure that all exceptions are logged without suppressing any errors. What best practice should he follow? A. Use a centralized logging procedure called from each exception handler. B. Remove all exception handlers to let errors propagate naturally. C. Handle only predefined exceptions and ignore user-defined ones. D. Place raise statements at the beginning of the block before processing. Answer. Correct answer. C. Centralized logging is critical, but handling only predefined exceptions without proper user-defined exception handling risks missing important error conditions. Removing exception handlers would allow unlogged errors and no recovery. Placing raised statements prematurely does not provide logging or control. Proper design ensures that both predefined and user-defined exceptions are captured and logged while maintaining control flow in robust and maintainable error. Question 4. Based on the information from recent performance tests, Mr. Lee notices repeated full table scans on a critical table despite having indexes. Which concept should he prioritize to reduce unnecessary scans? A. Analyze execution plans and implement appropriate hints or indexing strategies. B. Drop all indexes to force the optimizer to perform full scans consistently. C. Convert all queries to dynamic SQL to bypass the optimizer. D. Use on ESQL collections to replace table access entirely. Answer. Correct answer. C. Execution plans and hints directly inform optimization, making analysis crucial for reducing full scans. Dropping indexes is counterproductive, causing further performance issues. Dynamic SQL bypasses static query limitations and allows runtime optimization decisions, which can prevent repeated unnecessary scans. Replacing table access with collections is not feasible for persistent data and does not scale for large datasets. Correct tuning balances indexes, optimizer statistics, and dynamic SQL for efficiency. Question 5. From the perspective of ensuring security in an AI procedure that accepts dynamic user input, which approach best mitigates SQL injection risks? A. Use bind variables with DBMS assert input validation. B. Concatenate user input directly into dynamic SQL. C. Disable all dynamic SQL execution within the session. D. Execute DEL statements without any validation checks. Answer. Correct answer. B. Bind variables combined with DBMS assert validation securely separate data from SQL, preventing injection, concatenating input directly into SQL and its vulnerabilities. Disabling dynamic SQL prevents legitimate functionality and is unnecessary with proper safeguards. Executing EDL without validation is insecure. Correct security design ensures user input is sanitized, validated, and executed in a controlled manner using bind variables or DBMS assert routines. Question 6. When analyzing the benefits of using secure file lobs, Patel wants to optimize storage and retrieval of large XML documents. What features should she leverage? A. Deduplication and compression provided by secure file lobs. B. Store XML as blobs in basic file format without additional features. C. Convert XML to varchar to simplify storage. D. Disable caching for lobs to reduce memory usage. Answer. Correct answer. C. Secure file lobs support deduplication and compression, reducing storage costs and enhancing retrieval. Basic file lobs lack these performance optimizations. Converting XML to varchar is impractical for large documents due to size limits. Disabling caching reduces performance by forcing repeated disk reads. Leveraging secure file features provides efficient storage, compression, and fast access while maintaining integrity and enabling advanced operations such as streaming large XML content. Question 7. Considering the evidence from a code review, Mr. O'Neill observes repeated explicit cursor declarations that could be simplified. Which approach most improves maintainability without altering functionality? A. Replace explicit cursors with cursor for loops. B. Convert all cursors to autonomous transactions. C. Replace cursors entirely with dynamic SQL concatenations. D. Declare cursors in the global scope for all sessions. Answer. Correct answer. A. Cursor for loops automatically handle fetching, closing, and exception handling, reducing boilerplate and improving maintainability. Autonomous transactions alter transaction context unnecessarily. Replacing cursors with dynamic SQL may introduce complexity and security risks. Declaring cursors globally increases shared state and risks concurrency issues. The use of cursor for loops preserves functionality, minimizes code, reduces the likelihood of errors, following best practices for readability and maintainability. Question 8. Throughout the course of testing, AS is new and notices a performance bottleneck when repeatedly executing similar insert statements. Which technique should she implement to optimize DML execution? A. Utilize bulk binding with for all and returning into clauses. B. Execute each insert individually to monitor for errors. C. Move all logic to client-side processing. D. Use autonomous transactions to commit each row immediately. Answer. Correct answer. D. Bulk binding with for all and returning into significantly improves performance by reducing context switches. Individual inserts degrade performance. Client-side processing transfers load and increases network latency. Autonomous transactions for each row introduce overhead, fragment transactions, and compromise data integrity. Correct performance tuning relies on bulk operations and proper transaction control, ensuring large volumes of data are processed efficiently while maintaining consistent state and minimizing round trips between ESQL agents. Question 9. In light of recent developments in ESQL exception handling, Mr. Ahmed wants to implement a mechanism to capture errors in a multi-level procedure call hierarchy, which practice ensures robust error propagation. A. Raise application error with detailed messages propagated up the call stack. B. Suppress exceptions in subprograms to allow the main block to continue. C. Log exceptions only at the lowest level and ignore the calling procedure. D. Handle only predefined exceptions and skip user-defined ones. Answer. Correct answer. B. Raise application error propagates meaningful error messages up the stack and allows higher level blocks to handle them appropriately. Suppressing exceptions can hide critical errors, causing unpredictable outcomes. Logging at only the lowest level without propagation may miss context in higher procedures. Handling only predefined exceptions risks losing information on user-defined issues. Proper exception design ensures errors are propagated with meaningful context while allowing recovery or logging at multiple layers, aligning with Advanced PL best practices. Question 10. To what extent does using associative arrays for session-level data caching in ESQL improve application performance as observed by Okta Banerjee? A. Associative arrays reduce repeated SQL calls by caching key-value pairs in memory. B. Associative arrays increase disk I/O because data is persisted automatically. C. Using associative arrays eliminates the need for exception handling. D. Associative arrays force SQL statements to recompile each execution. Answer. Correct answer. A. Associative arrays store key-value pairs in memory, reducing repeated SQL calls and improving runtime efficiency. They do not increase disk I/O as they exist in memory and do not persist automatically. They do not remove the need for proper exception handling. Associative arrays do not force SQL recompilation as they interact with memory-resident structures rather than persistent tables. Effective use of associative enhances session-level caching and reduces unnecessary database round trips, aligning with performance optimization best practices. Question 11. When faced with frequent deadlocks in a procedure updating multiple related tables, ISTA Stewart wants to prevent such concurrency issues without reducing throughput. Which approach best addresses this problem? Implement consistent locking order across all DML orations. B. Disable all constraints temporarily during updates. C. Use autonomous transactions for every DML statement. D. Replace all updates with dynamic SQL to bypass locks. Answer. Correct answer. A. Deadlocks typically occur when multiple sessions acquire locks in different orders. Implementing a consistent locking order ensures that all sessions acquire resources in the same sequence, preventing circular waits. Disabling constraints compromises data integrity. Autonomous transactions create independent commits but do not solve inter-session lock conflicts. Dynamic SQL bypasses neither locks nor integrity checks. Proper deadlock management relies on design strategies, locking discipline, and predictable transaction sequences. Question 12. Considering the evidence from performance profiling is one notices that a stored function is repeatedly executed in SQL statements, causing significant overhead. What is the best optimization technique in this scenario? A. Use deterministic functions will result caching to reduce repeated computation. B. Convert the function to a procedure that returns values via out parameters. C. Remove the function entirely and perform computations in the client application. D. Disable SQL function execution inside SQL statements. Answer. Correct answer. C. Deterministic functions and result caching help, but moving computation to the client avoids repeated database context switches. Converting the function to a procedure does not allow its use in SQL expressions and limits flexibility. Removing the function entirely without a replacement is impractical if computation is required in SQL. Disabling ESQL SQL is infeasible for existing queries. Efficient design balances computation, caching, and context switching to minimize repeated function execution in SQL. Question 13. Through the lens of advanced exception handling, Istakaram wants to ensure that cleanup actions are executed even if multiple exceptions occur across nested procedures. What is the recommended PSQL approach? A. Place cleanup code in the final block using an exception section with raise to propagate errors. B. Handle exceptions only in the top-level calling procedure and ignore subprogram exceptions. C. Remove all exception handlers to allow natural termination. D. Use autonomous transactions for cleanup code to isolate it completely. Answer. Correct answer. D. Placing cleanup code in a separate autonomous transaction ensures it runs independently, even if the main transaction fails, guaranteeing resource release. Handling exceptions only at the top level risks missing specific error contexts. Removing all handlers can lead to unlogged errors and resource leaks. Using exception with raise in the same transaction may fail if the main block aborts prematurely. Advanced ESQL practice is to proper exception handling with transaction isolation for reliable cleanup. Question 14. In an effort to optimize bulk inserts into a large fact table, Johnson considers using collections to stage data before DML. Which option maximizes performance while maintaining transaction control? They use nested tables or arrays with for all and returning into clauses. B. Insert each row individually in A loop for precise error tracking. C. Stage data in client memory and execute multiple separate insert statements. D. Use dynamic SQL for every row to reduce compilation overhead. Answer. Correct answer. B. Nested tables and for all are best for high-performance bulk inserts, minimizing context switches. Row-by-row inserts degrade performance. Staging in client memory introduces network latency and increases complexity. Dynamic SQL per row adds compilation overhead and security risks. Correct design leveraged PSQL collections with for all, allowing efficient bulk operations while capturing affected row information by returning into balancing performance and data integrity. Question 15. To illustrate this point, Mr. Ollie wants to enforce fine-grained access control (VPD) on sensitive employee data. SQL technique achieves this without modifying existing application code. A. Create a policy function that returns a predicate and attach it to the table using EAS. B. Grant select privileges only to trusted users and revoke all others. C. Replace all queries with dynamic SQL that filter sensitive data. D. Use triggers to manually filter each select statement at runtime. Answer. Correct answer. A. EPD relies on policy functions that return predicates applied transparently to queries, enforcing access control without changing existing application code. Simply granting privileges does not enforce row-level security. Writing queries or using triggers for filtering is error-prone, inconsistent, and hard to maintain. EAS automates policy enforcement at the database level, ensuring secure context-sensitive access while preserving performance and application compatibility. Question 16. Based on the information from a code audit, Mr. O'Connor observes multiple dynamic SQL statements constructed by concatenating user inputs. Which best practice should he apply to secure the code? A. Replace concatenation with bind variables and EBMS assert validation. B. Continue using concatenation but log all SQL statements. C. Convert dynamic SQL to static SQL regardless of query flexibility. D. Remove all input validation and rely on database constraints. Answer. Correct answer. B. Using bind variables with DBMS assert prevents SQL injection by separating code and data. Concatenating input and only logging SQL is insufficient, leaving injection vulnerabilities. Converting to static SQL may not be feasible if the query structure is dynamic. Removing validation compromises security entirely. Prop PSQL design secures dynamic SQL by validating input, bind variables, and limiting string concatenation, ensuring robust defense against injection attacks while preserving query flexibility. Question 17. With respect to cursor management, is Fernandez wants to pass a query result set between procedures without opening multiple cursors repeatedly. Which approach is most appropriate? A. Use a ref cursor to pass the result set between procedures. B. Store the query result in a temporary table and reopen cursors in each procedure. C. Use explicit cursors declared globally and access them in all procedures. D. Convert the queries to dynamic SQL executed in each procedure separately. Answer. Correct answer. A. Ref cursors allow sharing of a query result set across procedures, reducing repeated cursor openings and enhancing maintainability. Using temporary tables increases EO and complexity. Globally declared explicit cursors introduce shared state issues and reduce encapsulation. Dynamic SQL per procedure incurs compilation overhead and potential injection risks. Advanced ESQL practice favors ref cursors, modularity, session-specific data handling, and performance while ensuring clean code design. Question 18. During the process of lob manipulation, Octogupta wants to perform partial updates on a large clob without loading the entire object into memory. The DBMS lob technique should be applied. A. The DBMS lob write append or DBMS lob write to modify sections incrementally. B. Convert the clob to varchar, update it entirely, and store back. C. Extract the clob to a file, edit externally, and reload. D. Disable secure file lob features to allow partial updates. Answer. Correct answer. DBMS lob write append and DBMS lob write allow in place modification of large lobs, minimizing memory usage. Converting to VARCHA is limited by size restrictions. Extracting and reloading externally is inefficient and risky. Disabling secure file features is unnecessary and does not enable partial updates. Correct lob handling uses incremental write techniques to efficiently manipulate large objects with all memory loading, preserving performance, data integrity, and transaction control. Question 19. From a practical standpoint, Mr. Smith needs to trace and profile to identify bottlenecks in data-intensive computations. Which methodology ensures accurate performance measurement? A. DBMS profiler to capture execution statistics of EESQL subprogram. Insert manual logging statements before and after every line of code. C. Disable exception handling to speed up execution during profiling. D. Run all queries in autonomous transactions to isolate timing. Answer. Correct answer. C. DBMS profiler captures precise execution metrics for each subprogram, identifying performance bottlenecks. Manual logging is time-consuming and prone to errors and can itself distort performance. Disabling exception handling does not improve profiling accuracy. Autonomous transactions isolate context but do not provide detailed profiling. Proper profiling relies on ESQL tools like DBMS Pro, combined with representative test data to understand hotspots and optimize performance effectively. Question 20. To better understand transaction behavior in but DML operations is Kapor implements, a procedure that inserts thousands of rows using for all with save exceptions. What is the primary benefit of this approach? A. Allows bulk inserts to continue despite individual row errors, capturing exceptions for review. B. Automatically rolls back the entire transaction on the first error. C. Bypass PSL exception handling for faster execution. D. Reduces context switches by converting the for all loop to dynamic SQL. Answer. Correct answer. A. Using for all with save exceptions enables bulk inserts to process remaining rows even if some fail, while storing exceptions in the SQL %bulk exceptions collection for review. Rolling back entirely would prevent partial success. It does not bypass exception handling, rather it integrates it efficiently. Converting to dynamic SQL does not inherently reduce context switches. Advanced PSQL bulk operations performance optimization with granular error management using save exceptions. Question 21. While examining a legacy SQL package, Ortega notices that multiple subprograms share common utility functions. She wants to reduce redundant compilation and improve maintainability. What is the best approach? A. Move utility functions into a package specification and body for centralized use. B. Duplicate the utility functions in each subprogram to avoid dependencies. C. Convert all utility functions into autonomous transactions. D. Replace utility functions with dynamic SQL calls. Answer. Correct answer. A. Centralizing utility functions in a package ensures a single point of maintenance, reduces redundant compilation, and allows shared access by multiple subprograms. Duplicating functions increases maintenance overhead and risk of inconsistencies. Converting them into autonomous transactions does not improve maintainability and may complicate transaction management. Dynamic SQL replacement introduces complexity and security concerns. Best practice is modular package design with reusable functions to enhance maintainability and efficiency. Question 22. Considering the evidence from performance profiling, Mr. Chen observes frequent repeated queries within a loop fetching large datasets. Where SQL strategy will most improve performance? A. Use bulk collect into a collection outside the loop and process in memory. B. Keep individual queries inside the loop to maintain row-level control. C. Execute queries using autonomous transactions for each iteration. D. Convert the queries to client-side processing to offload computation. Answer. Correct answer. D. Bulk collecting data into memory reduces repeated context switches and improves performance. Keeping queries inside the loop causes repeat SQL executions, degrading performance. Autonomous transactions do not optimize repeated query execution and may introduce overhead. Client-side processing may reduce database load but increases network latency and risks inconsistent transaction state. Correct design. Memory processing via collections or caching techniques to minimize repeated database access while maintaining efficiency. Question 23. During the process of exception management, ISTA-Sing wants to propagate custom error messages from nested procedures to the main calling block. Which is the recommended practice? A. Use raise application error with appropriate error codes and messages. B. Suppress all errors in subprograms to avoid halting execution. C. Convert all exceptions into warnings logged only in a temporary table. D. Disable exception handling to rely on default Oracle messages. Answer. Correct answer. B. Raise application error allows propagation of meaningful custom messages, making it easier for the main block to handle errors appropriately. Suppressing errors is unsafe as it hides critical issues. Logging only as warnings without propagation does not allow higher-level handling. Disabling exception handling exposes raw database errors, reducing control. Correct exception propagation ensures that errors carry context, maintain transaction control, and allow structured handling across multiple nested subprograms. Question 24. A demonstrated by a recent audit is Kumar notices repeat DML statements with single row inserts in a data migration procedure. Which method optimizes performance while preserving data integrity? A. Use for all with bulk collect and save exceptions to perform batch inserts. B. Continue single row inserts to monitor errors individually. C. Execute dynamic SQL per row to reduce compilation overhead. D. Disable constraints temporarily to allow faster inserts. Answer. Correct answer. A. Using for all with bulk collect reduces context switches and improves performance when handling large datasets. Single row inserts are inefficient. Dynamic SQL per row increases compilation overhead and may introduce SQL injection risks. Disabling constraints improves speed temporarily but risks integrity violations. Best practice combines bulk DML with exception management, ensuring high performance migration, while capturing and reviewing any row-level errors without compromising database consistency. Question 25. To what degree does using ref cursors enhance modularity when multiple procedures need to share a query result set as observed by Easter Thompson? A. Ref cursors allow passing result sets between procedures without reopening cursors. B. Global explicit cursors improve modularity better than ref cursors. C. Temporary tables are more efficient than ref cursors for sharing data. D. Dynamic SQL per procedure is safer and improves modularity. Answer. Correct answer. C. Ref cursors enable procedures to share query results efficiently, reducing repeated openings and improving modularity. Global explicit cursors risk shared state issues and reduce flexibility. Temporary tables require additional EO and maintenance overhead. Dynamic SQL per procedure does not inherently improve modularity and introduces security concerns. Proper use of ref cursors allows modular, flexible, memory-efficient data sharing across ESQL components, supporting maintainable and scalable code. Question 26. From a practical standpoint, is Davis needs to handle large clubs containing JSON documents, which technique allows reading and writing portions efficiently without loading the entire object into memory. A. With DEMS-lub, read an EMS-lub, write with offsets for incremental operations. B. Convert clob to varchar for easier manipulation. C. Export the entire clob to an external file, edit and reload. D. Disable secure file features for better performance. Answer. Correct answer. D. DBMS lob. Read and write allow efficient partial access to lobs without consuming excessive memory. Converting large clobs to varchar is limited by size restrictions and is impractical. Exporting to files adds EO overhead and complexity. Disabling secure file features does not improve partial lob handling, it merely removes storage optimizations. Correct practice uses incremental lob operations with D. Lob to efficiently read and modify large objects while preserving performance, memory efficiency, and transactional integrity. Question 27. Under the assumption that an error function is called repeatedly in SQL statements across sessions, Istijao wants to reduce redundant executions. Which method is most effective? A. Declare the function as deterministic and enable result caching. B. Convert the function to a procedure without parameters. C. Disable function execution in SQL statements. D. Move function logic to the client application for repeated calculations. Answer. Correct answer. A. Deterministic functions with result caching store prior results, eliminating repeated computation for identical inputs, improving performance. Converting to procedures limits SQL usage. Disabling function execution in SQL is impractical. Client-side computation increases network latency and shifts transaction control outside the database. Best practice leverages deterministic functions and caching database integrity while optimizing repeated function calls inside SQL queries. Question 20. While analyzing a package, Mr. Hassan finds multiple nested loops performing similar calculations. Which technique improves efficiency without changing the output? A. Use collection-based bulk operations with for or bulk collect. B. Keep nested loops for precise row-by-row processing. C. Convert loops into autonomous transactions for better performance. D. Replace loops entirely with dynamic SQL execution. Answer. Correct answer. B. Collection-based bulk operations reduce context switches and improve efficiency when handling large datasets. Nested loops preserve correctness but are inefficient. Autonomous transactions do not optimize iteration performance and may complicate transaction consistency. Dynamic SQL per loop iteration adds compilation overhead and increases security risks. Correct optimization uses bulk operations where possible, preserving logical flow and data correctness, ensuring scalable and maintainable SQL code. Question 29. Throughout the course of debugging, Ramirez wants to trace a package execution to identify which subprograms consume the most resources. Which Oracle tool is most appropriate? A. DBMS Profiler to capture execution statistics for SQL subprogram. B. Manual logging using DBMS output before and after every statement. C. Disable exception handling to speed up execution during profiling. D. Use autonomous transactions to isolate timing for each subprogram. Answer. Correct answer. DBMS Profiler provides structured, detailed profiling information with minimal impact on performance. Manual logging is error-prone and can distort execution timing. Disabling exception handling does not yield accurate profiling metrics. Autonomous transactions isolate execution but do not provide structured profiling statistics. Best practice uses Oracle profiling tools to systematically analyze, perform, identify hotspots, and guide optimization without altering transaction logic or control flow. Question 30. Given the circumstances of handling sensitive employee data, Mr. Patel wants to enforce row-level security without modifying existing queries. Which approach is most effective? A. Apply virtual private database policies using EAS with a predicate function. B. Write all queries to filter data manually and where clauses. C. Grant select privileges only to trusted users. D. Use triggers to enforce row filtering at runtime. Answer. Correct answer. EED policies at EAS enforce row-level security transparently without changing queries, providing a centralized, maintainable solution. Manually rewriting all queries is error-prone, difficult to maintain, and risks inconsistent enforcement. Granting privileges alone does not control row-level access. Using triggers for filtering adds overhead and complexity. Correct practice leverages policy functions and VP to secure sensitive data consistently while keeping application code intact and maintainable.